Hello everyone. In this video, we are going to understand about the 2's complement representation. So this representation is one of the important representation to represent the negative integer number or the signed integer numbers. So I have already discussed about the 1's complement representation, which is also used to represent the negative integer numbers. So you can find the link of that video in the number system playlist in the description below or in the I button also. So this 2's complement representation is necessary to understand because it is used in our modern computers to represent the signed integer numbers. And it is also important with respect to your competitive exams like GATE, UGC NET, because most of the questions are asked from this 2's complement representation also. So if you have not subscribed my channel, please subscribe my channel and press the bell icon for further notification of the videos. So let's start. So we have seen in the previous video that there are actually three different ways to express negative integer numbers or the signed integer numbers. So we have discussed that signed magnitude representation and we have discussed the 1's complement representation in the previous videos. So in this video, we are going to understand about the 2's complement representation. For that, you should know that how 1's complement representation works. So you can watch the video of the 1's complement representation. So now let's start with the 2's complement representation. So these are the steps to convert a given decimal number into the binary 2's complement representation. And to understand all these steps, let's take examples. So let's say you are given a decimal number and you have to convert them into a binary number using the 2's complement representation. Let's say you are given plus 13, that is a positive number. Okay. So for positive number, the steps are actually simple. Okay. So these steps are actually for the negative numbers. You have to take care of this. Okay. So for positive 13, what you have to do? You have to simply write the binary form of 13. Okay. Normal 13. So normal 13 is like 1101. Okay. You can say like this is having weight 1, 2, 4, 8. Okay. So this is the weight. So this is the 13. Okay. Now you have to take care that you have to always put one extra bit. Okay, so positive number is there, you have to just put 0 here. Okay, so this 01101 is the binary representation of the plus 13 in 2's complement representation. So you can represent something like that also. This is the 2's form, okay, of the plus 13. Now let's represent minus 13. Okay, so how you will represent this minus 13 in 2's representation? Okay, so for this, what are the steps you can see here? So these two steps are actually the same steps as we have seen for the 1's complement representation. So these steps says that first you have to write the positive representation of the given number. Okay, and you have to take one extra bit also. So that means first you have to write the representation of the plus 13. So plus 13 is written as this way, right? This is 13 and you have to put one extra bit. So this is 01101. Okay, so this step is over. Now you have to flip all the bits in this binary number. That means you have to convert 0 to 1 and 1 to 0. So if I do this, this 0 will be converted to 1 and this 1, 0, this 1 is made 0, then 1 and last one is made 0. Okay, so till this point, actually we have got the 1's complement, right? Because these steps are the same as we have seen for the 1's complement. Now the next step in this 2's complement representation is we have to add 1. Okay, that is we have to plus or we have to add 1. So now 0 plus 1 is 1. This is 1, 0, 0, 1. Okay. So this is the final 2's complement representation. Okay, or you can say this is minus 13. Okay, in 2's complement representation. So you can simply say you have to first find the 1's complement representation and then just add 1. Whatever you get, this will be your minus number or negative number representation. Okay, so let's see one another example. Let's say you have to represent minus 45 in 2's representation. So again, first step is you have to first write the plus 45 representation. Okay, so plus 45 is this one, 101101. Okay, and as I have told you, you have to put one extra bit. That is, you have to put actually 0. That extra bit will be 0. Okay, now this is positive 45 in 2's representation. The next step is you have to flip all these bits. Okay, so this will be 1010010. That means you have found the 1's complement representation. Now one last step will be you have to add 1. Okay, so this will be added with this. 0 plus 1 is 1, then this 1 is copied here, and 0 0 1 0 1. Okay, so this is your final answer. That is, this is the representation of minus 45 in 2's complement format. Okay, so these are the steps to get the 2's complement representation for a given decimal number. Now let's see if we are given binary form, okay, and then how we can get the decimal representations. So these conversions we have just seen. Now let's see these conversions. So we are given the binary numbers in the 2's complement formats, and we have to convert them into the decimal number. Okay, so we have to find what will be the decimal number corresponding to this and corresponding to this. Okay, so you can see here that last bit is 0. Okay, so whenever in 2's complement the last bit is 0, that means the given decimal number, it will be actually positive. Okay, or you can say this is the positive representation of the positive number. Okay, so for that what you have to do, you can just take all the bits as the magnitude simply. Okay, so it is like 1 2 4 8, and last is actually 16, but 16 multiplied 0 will be simply 0. Okay, so it will not contribute anything. So this is like 8 plus 4 12 plus 1 13. So this is simply 13 in decimal, and we can see here also. Okay, so just 0 1 1 0 1, this we have got after converting this into binary number. Okay, so same thing we have got in the reverse direction also, right? So you can put plus 13, or you can simply write 13. This is one and the same thing. In the second question, you can see that the last bit is 1. So in 2's complement, whenever the last bit is 1, you can be sure that the given decimal number, or the decimal number that you will be getting, it will be negative number, or this is the representation of a negative number. Okay, so to get the decimal number from this representation, the steps are very simple. Whatever steps you did for converting a decimal number or a negative decimal number to the binary number, the opposite of those you will do here. So what you did for converting minus 13 to this representation, you first write the 13 representation, that is 0 1 1 0 1. Okay, and then you flip them. Okay, 1 0 1 0, and then you added 1. Okay, you got this thing. The same thing you will do here. You will actually first flip them. Okay, first flip these bits, and after that you will add 1 to this flipped answer. Okay, so what does it mean? So the given numbers were these. Okay, this. Now you have to first flip them. So it will be 0 0 0, then this 0 will be 1 0 and 1. Okay, and then you have to add 1. Simply add 1. So 1 and 1 will be your 0, and carry will be there. So 1 and 1 again will be, it's like 1 0. So it will be like 0, and carry will be 1. Okay, so it will be 1. Now this will be simply copied. So I have added 1. Okay, now I got this thing, right? So this 1 is telling me the answer will be negative. So answer will be negative. Okay, and after that what I did all these things. I flipped, and then I added 1. Okay, so I got 0 0 1 1 0 0. That means this thing. Now what is the next thing? You will simply put minus, and then you will interpret all these bits in the decimal number. So here you can see that this is having weight 1, then weight 2, 4, and 8. Okay, so it will be 8 plus 4 12. So it is 12. So total answer is minus 12. That means this number is minus 12. Okay, in decimal form. So this is the way that you can convert a given 2's complement binary number into a given decimal number. Okay, now let's take one last example. Suppose we have to convert this 10011 into decimal number. So again, what we have to do? This 1 is telling me that the final answer will be negative. So there will be negative of some decimal number. Okay, so for that, again, what you have to do? You have to flip this. Okay, so after flipping or converting them to zeros and 1, it will be 1 to 0. 0 will be converted to 1 1 0 0. Okay, and then simply add 1. Okay, so you will be getting 0 1 1 0 1. Okay, now this is like minus of this total answer. Okay, minus sign you have to put. So this will be minus of, this is 1 2 4 8. That means this is 13. So this is minus 13. Okay, so this given number 10011 is minus 13. And here also you can see that 10011 is minus 13 when we were converting from this direction to this direction, right? So we have got the correct answers. So this is the way you can convert the given decimal number to binary number, or a given binary number to the decimal number in case of 2's complement representation. Now let's understand the concept of the range in case of 2's complement. So what do I mean by the range? So here I mean that if you are given certain number of bits, what will be the different numbers that you can represent, or they are allowed in those bits. Okay, so let's take the example. For example, you are given 2 bits. How many different unique numbers you can make? So you can form actually 4 different combinations, right? Now if you convert these 4 different binary numbers in 2's complement representation, so you will be getting like these 2 numbers will be positive, these will be negative. How? This 0 is telling me this will be positive, and 1 is telling me that the number will be negative. So this will be like simply positive of 0, because I can take both the bits as the magnitude, or I can simply take this bit only. Okay, now this will be again positive of 0, 1 is simply 1. Okay, now in case of negative, I have to take care. I have to first convert them to 0, 1. That is, I will flip. Then I will add 1. Okay, I will simply add. Okay, so it will be like how much? So 0, 1 plus 1. 0, 1 plus 1. It will be 1, 0. Okay, and 1, 0 is how much in decimal? It will be 2. So it will be negative 2. Now this 1, 1 is again flipped to 0, 0. Okay, so 0, 0. Now plus 1, it will be 0, 1. Okay, and 0, 1 is 1. Okay, it will be negative. So these are the different numbers that I can make, or I can get in 2 bits 2's complement representation by these numbers. Okay, so you can see if I represent them on the number line, I got 0, then 1. Okay, here it is minus 1, and here it will be minus 2. So these 4 numbers I can get. So for 2 bits, my range of numbers will be from minus 2 to plus 1. These are the different numbers I can represent. Okay, now here you can see that we have only got one representation of the 0, that is only plus 0 or the simply 0. But in case of the sign magnitude and 1's complement representation, if you have seen my previous videos, in that you have seen that we have the plus 0 also, minus 0. Okay, so this is actually the advantage of the 2's complement representation, that we have only the one unique representation of the 0. Okay, I will be telling you the other advantage of the 2's complement on the 1's and the sign magnitude representation in the other videos. So for the time being, let's move forward. For example, you are given 3 bits, then how many different number you can make? So you can make 8 different numbers. Now if you convert them into the decimal number according to the 2's complement, so you will be getting all these numbers. So you can say these are simply positive numbers and these are the negative numbers. As you can see, 1 is telling me that negative numbers will be these. Okay, so these are simply like 0, 1, 2, 3. I think there is no difficulty in finding the decimal form of these. But here you have to take care. This is the negative number. So to find the decimal number, what are the steps? Again, flip them and then add 1. So 0, 1, 1 plus 1, you will be getting 1, 0, 0. And this 1, 0, 0 in total, it will be 4. Okay, 1, 0, 0 is 4, but it will be negative. The same way 1, 0, 1, if I convert or flip, if it will be 0, 1, 0. Then plus 1, I will be getting how much? 0, 1, 1. So 0, 1, 1 in total, it will be simply 3. But I have to put minus sign as it is negative. So in this way, this will be minus 2 and this will be minus 1. So you can say that the biggest number will be, you can say, positive of 3, and the smallest number will be minus 4. Okay, this will be minus 3 and so on. Here it will be 0. So this total 8 different number I can make. So for 3 bits, the range will be from minus 4 to positive 3. Okay, so if I ask you for n bits, what will be the range of numbers possible? So you can say this is the formula that I will be getting for n bits. Okay, now if you observe here that there is no minus 1 here, that means in case of sign magnitude and the 1's complement, here we have 2 to the power n minus 1, minus 1 was there, but there is no minus 1 here. Okay, so this you have to take care in case of 2's complement formula. Now if you fit this n equal to 2 in this formula, you will be getting like minus 2 to the power 2 minus 1 minus 1, right? And sorry, this minus 1 will not be there, and plus 2 to the power 2 minus 1 minus 1. So this will be 2 power minus 1. This simply will be your 2, and this will be negative, and this will be like 1 lesser. Okay, so 2 to the power minus 1, it will be 1. 2 to the power 1 is like 2 minus 1. Okay, so it will be 1, positive of 1. So we got the same thing. Okay, that means the formula seems to be correct. Same for n bits, you can see that you will be getting this much only, right? Now before moving further, let me tell you one important thing. Let's say you have to represent plus 4, okay, in 2's complement binary form. So for that, what are the steps? The steps are simple. Write 4 1 0 0 and add 1 extra 0. Okay, this is the correct representation. But if you write 1 0 0 for the plus 4, okay, this is wrong. Why? So for example, if you write 1 0 0, okay, and somebody asks you that this is a 2's complement representation, tell me what will be the decimal number. So as we have seen that if we are having the last MSB bit as 1 in 2's complement, that means the number will be simply negative. And to get the magnitude, what are the steps? You just flip that. Okay, if you flip, you will get 0 1 1 and then add 1. So you will be getting 1 0 0 and read all these bits for the magnitude. So it is 1 0 0 means 4 4, but it will be minus 4 as we have put minus sign because it was 1 here. So that means we got minus 4. That means 1 0 0 is actually represented as minus 4 by the computer, and computer will be giving me minus 4 as the answer. This plus 4 representation is not equivalent to 1 0 0. It should be 0 1 0 0. Now the thing that I want to tell you actually is, if you have to represent negative number, that is let's say minus 4. So steps are, you have to first represent plus 4. It will be 0 1 0 0. Okay, this 0 has to be there, and after that you flip them 1 0 1 1. You add 1, you get 1 1 0 0. So this is minus 4. But here you can see this 1 0 0 was also telling me that it is minus 4, and 1 1 0 0, it is also telling me minus 4. So actually this is also correct and this is also correct. Okay, because we converted this 1 0 0 as minus 4. So the thing is, let's say here we have got the answer in 3 bits, here we have got answer in 4 bits. So the thing is, for example, let's say when you were representing plus 4 as 1 0 0, let's say, and you do not put extra 0, okay, and you simply converted or flipped it as 0 1 1, and then you add 1, you got 1 0 0, okay, and you say this is minus 4. So although you got 1 0 0, which is actually the correct representation, but it is advised that you start from the good habit. You put extra 0 whenever you are representing any negative number. Okay, whenever you are representing negative number, the first step is represent the positive representation. So this is the magnitude and add extra 0. Okay, 4-bit number. So actually why this habit is good, actually let's say if you are multiplying two numbers 5 into 15, and the question says that these are the signed numbers, and let's say you are multiplying these numbers using Booth algorithm. So Booth algorithm is one of the algorithm to multiply two signed numbers that we will see in the later videos. So in that algorithm you have to first convert them into the binary number. Let's say if you are representing this 5 as 101 simply, okay, and you are not putting this 0 here, okay, and simply you are saying 15 is like 1111, okay. But if you do not put again 0 here, then you will actually get the wrong answers, okay, after applying that Booth algorithm procedures. So the simple thing is always put one extra 0, okay. And the reason you may have got that, if you represent 100, okay, this 100 actually not 5, this is something else. This 1 is telling me that this will be a negative number, okay. So all the answers you will be getting after this, they will be wrong in the Booth algorithm cases. So there can be many other examples also where you can get the wrong answers, okay. At some places you may get the correct answers, but the good habit is always put extra 0, okay. So let me ask you one simple question before ending this video. So you have seen the formula for the range. So you have to tell me what will be the range for the 8-bit numbers in case of 2's complement. Okay, so you can pause the video and you can find the answer first by yourself. I hope you have got the answer. So you have seen the formula that for n-bit range, you have this formula, right? So after you put n equal to 8 in this formula, you will get this thing. And if you solve them, you will get this one, okay? And after that, you will be getting this one. So 2 to the power 7 is 128. And this is 127. Okay, so this is negative of 128 to 127. All the numbers like minus 128, minus 127, so on 0, 1 till 127, they can be represented by 8 bits in case of 2's complement representation. So this is the range minus 128 to plus 127. Now just to tell you, plus 127 can be represented as this way in case of 2's complement, okay, and minus 127 it can be represented this way. So for minus 127, what were the steps? First you have to represent plus 127, then you will flip them, okay. So after flipping you will be getting this one, okay, and then you simply add 1, okay. So you will be getting actually this answer. This is minus 127. And let's say if you have to represent this minus 128, so here you can see this is actually 128 and you are adding extra 0, okay. Now minus 128 will be this one, so you will be first flipping them, okay, 1 1 1 and this 1 1 1, and then you will be adding, so you will be getting all these zeros, okay, and here it will be 1 1, so you got this answer, right? So this is minus 128, but these are actually how many bits? Total 9 bits, okay, total 9 bits, but we are saying that in 8 bits in case of 2's complement we can represent minus 128. So how is it possible? So actually if you represent this minus 128 using 8 bits, that means only this answer will be considered. So that means this is also minus 128, okay, this means the same thing, right? So just to verify, if somebody gives you this number, this 8-bit number, and he say you that this is a 2's complement number, tell me what will be the decimal number. So I should get actually minus 128. So let's see how. So this one is telling me that this is a negative number, okay. Now to get the decimal number, what I will be doing, I will be flipping this, okay. So this will be this one, and then I will be adding, so I will be again getting this one, okay. Now I have to take all these bits for the magnitude for here, right? So these all bits from 1 to all 7 zeros, it is actually 128 in decimal. So I got minus 128. So this means using 8 bits also minus 128 can be safely represented, okay. But it does not mean that plus 128 can be represented in 8 bits, okay. Plus 128 will be this one. You cannot represent this using this, okay. That's why plus 128 cannot be represented using 8 bits, as you can see here, okay. So these are actually some important things that you should understand, that how this range concept is being applied and what are the right or the correct way to get the answers, okay. We will be seeing more questions in the upcoming videos. So if you have any question, comment, suggestion, please write down into the comment box. Do like and share this video, subscribe the channel and press the bell icon for further notification. So see you in the next video. Till then, goodbye.